Hello guys, in this video, we're going to learn how factory I/O software can connect to Delta PLCs. First, I'll write and test a simple PLC program, which will be used later. During that, we'll learn force and also set commands, to change Boolean data. Then, we'll have a short introduction to factory I/O software and design a simple system. After that, to connect this software to my Delta PLC, I will create an OPC server using KepServerEX software. Finally, we'll be able to run the design system inside factory I/O software, by the PLC program. Before we get started with today's video, I just wanted to inform you about all the great content we have been releasing on the plcgoods YouTube channel, which includes industrial automation PLC programming, HMI, and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Alright, let's start the project with a simple program to turn on an output. So, first a new project must be created. Now, let me write a simple program. As you know, letters X and Y refer to PLC input-output, and X0 and Y0 are the first digital input-output addresses. Also, we can use PLC memory with the letter M. It can be used to store industrial process parameters, or share stored data with other devices such as HMIs. Now, let's test the program like previous videos. As you can see, I can use the first switch to turn on the first LED. Sometimes, we may need to use the force option. For example, when the switch is broken, and we have no time to repair it. At this time, we can use ISPSoft to change the value of X0 in the PLC program. As you can see, now my program does not work based on the connected switch. Well, this option has two states: force on and force off. Note that, if this option is used, a lock symbol will appear beside the selected address. Remember, this option is not used in normal conditions. We can use release items to remove the state. However, it is normal for the PLC memory to change by other devices like its connected computer or HMI. As you see, the force mode is disabled. Instead of that, I can use set commands to turn on or off the first LED. Well, these two contacts can turn on the first LED. But the first contact uses the first digital input, and the second one uses the PLC memory. Okay, now, let me open factory I/O software, and design a simple system to learn it. If you follow our channel, you may know that I can use the software to simulate some industrial process. Note that, this software can be downloaded without any cost for 30 days. First, let me insert a belt conveyor to design a new system. Now let me use the screen flash. It will put some boxes on the belt conveyor. To change its height from the ground, I press the V key on the keyboard and then move the mouse. Well, let me use arrow keys to the end of the belt conveyor, and then add a chute conveyor. Now, let's use the red flash at the end of the inserted chute. It will take the boxes out of the design system. Alright, I am going to control the system with the previous PLC program. First, let me test it manually. Here are two icons: sensor tags, and actuator tags, which can be used to display or hide equipment tags. Sensors can be connected to PLC inputs, and actuators connect to PLC outputs. This tag, belt conveyor 1, refers to this motor. It can be connected to PLC outputs. In the run mode, if I activate this tag, related to the belt conveyor motor, it will move inserted boxes. Now, let's change how the boxes are inserted. I increase the max and min time. These items determine the time between each inserted box. I also want to have only two small and large boxes. Let's test the design system again. Okay, as you see, there are only two box types. Note that, I want to control the belt conveyor with my PLC. So, I must click here to release forced value. Now, let me design a simple control box that has two push buttons. It will be used to start and stop the belt conveyor. Alright, as you see, each inserted push button has two tags. They have both sensor and actuator tags. Their actuator tags refer to their internal light. In this project, I will connect them to my PLC inputs using their sensor tags, which refer to push button state. Note that, the stop push button is normally close and the other one is normally open. Also, as you see, each tag can be renamed easily. Now, let's see how inserted equipment like push buttons and belt conveyor can be connected to my PLC. I must open the file menu and select the driver's item. As you may know, we prepared two courses about some PLCs of Allen Bradley and Siemens companies. You can see them on our YouTube channel. There, we explained how factory I/O software can be connected to these PLCs directly. Note that, here is not any item related to Delta PLCs, but I can connect it to an OPC server with this item. OPC Client Data Access. Now, factory I/O is trying to connect to an OPC server. Note that, on another side, I can connect my PLC to the OPC server. So, factory I/O will be able to use the PLC data through the OPC server. OPC is a software interface standard that allows Windows programs to communicate with industrial hardware devices. The OPC server is a software program that converts the hardware communication protocol used by a PLC into the OPC protocol. To have an OPC server on my computer, I can use KepServer software. This software is an industry's connectivity platform that provides a single source of industrial automation data to all of your applications. The platform design allows users to connect, manage, monitor, and control diverse automation devices and software applications through one intuitive user interface. This software can be found on the internet easily. Its demo version is fully functional and runs in a 2-hour, time-limited mode until purchased. The demo period can be repeated at any time by stopping and starting the application. There are no other limitations to the product. Channel, device, and tag counts are unlimited. To connect a device, first, a channel must be created. As you see, the new channel can be created based on different protocols. Or for different PLC types of different companies, like Allen Bradley, Honeywell, Mitsubishi, Omron, Siemens, but again, there isn't any Delta PLCs. But we can use a standard protocol to connect Delta PLCs to the OPC server. If your Delta PLCs has an Ethernet port, you can use this item, but let me use this one, Modbus ASCII serial. Note that, Modbus is a serial protocol. The default settings are usually appropriate for the new connection. Here, I must select the appropriate COM port. Let me open COM-MGR software. As you see, I used COM5 to connect ISPSoft to my PLC. Now, let me select another connection here, to release this port, and then use that inside the KepServer software. Now, let me click on the next button and use default settings. Note that, you can create different channels to connect different devices like PLCs and HMIs to the OPC server. After creating a channel, the next step is to select devices and their settings, which want to connect to the OPC server through the created channel. My PLC model is DVP20SX2. Let me write it here. Note that, I can use any arbitrary name. Again, let's click on the next button to use default settings. Now, I must determine the data of the selected device, that must be shared with the OPC server. Remember, this is the simple program, which has been transferred to my PLC. It uses the first digital input and memory to turn on the first digital output. I want to share the state of these addresses with the OPC server. Well, here is an important point. What addresses are used for these, through the Modbus protocol? Let me open another document. You can find it on the internet easily. Let me search Modbus addresses inside the document. Well, this table can determine the PLC device address through the Modbus connection. For example, the Modbus address of the first digital input in the PLC program, with the letter X, starts from this number, 101025. Let me copy this number. Now, inside the KepServer software, I have to specify the new tag name, description, and properties of the first digital input. Let me start the new tag name with the word Delta. Note that, you can write anything here, but I advise you to use a meaningful name. The first digital input can turn on the first digital output, so, I write start inside the description field. The main part is the address field. Here, let me paste the copied address. 101025. Alright, the new tag has been created inside the OPC server, which will read the first digital input state. Now, let's create another tag. I want to connect it to the first digital output. Y0. So, I need to use this Modbus address. OK, after the name field, I write belt conveyor inside the description field. Because I will use this tag to turn on the belt conveyor inside factory IO software. Finally, I paste the copied address here. Similarly, let's create another tag, related to the M0 address, the first digital memory address of the PLC. Alright, I've created all tags, related to the PLC program. Now, let's click on this icon. Quick Client. In this window, you can see all channel and their devices. Let's select the DVP20SX2 device, of the first channel. On the right side, we can see created tags and all related information. Let's have a better view to see all columns. As you can see, the data type of all created tags is Boolean. Now, their value is 0. The next column shows the last time, when a tag is updated. Based on this column, the connection quality of all tags is good, and the last column determines how many times a tag has been updated. Now, let me use the first digital input to turn on the first digital output. As you see, the OPC server can display the state of the first digital input and output. Alright, I've connected my PLC to the OPC server successfully. Now, let's connect factory IO. First, let me select the OPC server, created by KepServerEX software. Well, I've defined only 3 tags. But sometimes, different devices are connected to the OPC server, and the number of defined tags will be too many. Remember, I used the Delta word at the beginning of each tag. So, let me write it here, and then click on Browse Items. So, Factory IO will find tags inside the selected OPC server, which are started with the Delta word. Alright, the 3 defined tags have been detected by Factory IO. Now, let me connect the Start Push button to my PLC. As you see, it can't connect to the first digital input, because this tag gets its value from the real connected switch. So, Factory IO cannot change it through the OPC server. But I can connect it to PLC memory without any problem. So, the Start Push button can change this contact inside the PLC program. As you know, it can turn on the first digital input. So, let me connect it to the belt conveyor. Now, let's test the project. Well, based on the PLC program, I can use the first digital input to turn on the first digital output, in other words, start the connected belt conveyor. Also, I can use the Start Push button, to change the M0 contact, to start the belt conveyor. Note that, similarly, Factory IO can be connected to other types of PLCs. In the next video, this project will be extended to sort small and large boxes. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.